All right, so let's do the last one for the quiz, 7.4. So here we have question number 1. Excuse me, sorry. Okay, so question number 1. The triangles shown to the right are similar. Write a correct similarity statement. So they're telling me that this triangle and this triangle are similar. And how do we know that? We just learned that, that if you have two triangles and they have two congruent corresponding angles, that the two triangles are similar. That's the AA similarity postulate, right? So let's read. Remember guys, we decide how we name a triangle. So let's start with, well, let's assume we don't know. Let's start with this ACB. So is A congruent to C? A, C. No. So that one's not right. What about this one? A is congruent to E, A to E. Yeah. No arc, no arc. B is congruent to D, B is congruent to D, and C is congruent to D. C is congruent to C, which is right here because they're vertical angles. So that one looks good. Let's just keep going just to check, just to like for fun, right? So A is congruent to D. Is it? A, D, nope. This has no arcs, one arc. A to C, no arc to two arcs. So no. So the answer is B. So now number 2. Determine whether the given triangles are similar, okay? So let's see if they're similar. Well, I have two triangles with corresponding with what looks like I only have side lengths. So what is the smallest side length in this triangle? Well, it is 28. What's the smallest side length here? 7. What's the second smallest? 48 to 12. And 56 to 14. 56 to 14. And if we also want to take a look at it here, look, you have AB to HG. So AB to HK. AB to HK. So 56 to 14, that works out. That one's good. What about this next one? BC to KG. So BC to KG. 48 to 12. And the last one, CA, 28 to GH 7, 28 to 7 right here. Okay, so now let's see if these are congruent. The greatest common factor of 28 and 7 is 7. So that'll turn into what? 4/1. Greatest common factor here is 12. What does that turn to? 4/1. Here, you're also gonna have what? Let's try on my calculator. Let's try 56 divided by 14, which is 4. So 4/1. So not only are these two triangles similar by the SSS similarity theorem, so B, cool. We also know that the scale factor would be 4/1, okay? Now let's look at this one. Are the triangles similar? Well, my first green flag, which is good, is that I have 80 degrees and 80 degrees. So now I know that I have the SAS similarity theorem, which tells me that if I have an included angle, congruent angle, okay, and I have two pairs of corresponding proportional sides, not corresponding congruent sides. That was the SAS postulate that we learned to prove congruency of triangles. Now we're talking about similarities. And in the SAS similarity theorem, these corresponding side lengths must be proportional. So let's see if they are. Look, I have GUA, EFB, GUA, EFB, GUA, EFB. So we can compare the side lengths pretty easily there. So UG, the 16, is to GU to EF. What is EF? 20. And what's my other side length? I have GA over here, GA, GA is the same as EB. Do I have an EB? Yeah, it's 15. So I'm gonna have 12 over 15. Now, let's simplify this. What is the greatest common factor of this? Looks like it's 4. 4, so I'm gonna have 4 over 5. And the greatest common factor here looks like it's gonna be 3. So I'm gonna have 4 over 5. So now I know that the included angle is congruent and the corresponding side lengths UG to EF and GA to BE are what? They are proportional. And if you have corresponding side lengths that are proportional, what do I know about the triangle? That they are, well, if I have side lengths that are proportional and an included angle that's congruent, I know that the true triangles are similar. So what is it that I have? GA, oh look, they want me to write like this. So what is 16? So the 16 that I wrote over here, this 16 is the GA, this 20 is the, wait, GA is the GU. Okay, so they just wanted me to write it a different way. So I wrote it in a different format. I probably reciprocated it and then I switched the means or something. So GA, so if we just write it like this, GA is what, 12. What is BE? BE is 15. What is GU? GU is 16. EF is 20. So what is 12 times 20? Pretty much, oh, I have the same thing. I just put this one second and this one first. Okay, so I know I have the same cross multiplication, so my answer is still gonna be correct. So this is the one that's congruent. These are the ones that are similar because the triangles are similar because GA to BE is equal to GU to EF. So if they're equal, then I know that these side lengths, GA, BE, GU, and EF are corresponding side lengths. And what do I know about corresponding side lengths in similar triangles? They are proportional. And I know that G and E are the included angles in this SAS. So this satisfies the SAS theorem, similarity theorem. Okay. So let's take a look at this. Okay, so let's say we didn't know that. Okay, cool. So determine whether the triangles are similar. Okay, well, the first thing I notice is that I have pretty off the bat is that C and C are congruent. Okay, so what type of line is this? This is R. What type of angle is this? RCA is congruent to BCV. Or ACR is congruent to VCB. So I have that right here. So this is good. Is A congruent to V? No. Oh, we don't know that yet. Okay, so let's just keep looking. Okay, so now let's keep looking because I'm getting too ahead of myself. So now I know I have two parallel lines right here. Parallel. And now, if I want to say that this is my transversal, I can say that RAC is congruent to BVC. And how do I know that? Because aren't these just alternate interior angles? So now, what angles are these? This is angle A, and this is angle V. So far I have, so what are some things that I have? I have that RCA, angle RCA, this one, RCA, is congruent to BCV. It's congruent to BCV. And I also have that angle A is congruent to angle V. Angle A is congruent to angle V. Okay. Okay, so do I have any of those anywhere here? So I have that, look right here on my A. So I have that angle A is congruent to angle V, right here. I also have that angle ACR is congruent to VCB, right here, because of vertical angles. Here, to be more proper, let me put 2 arcs, right? So now, do I know anything about my side lengths here? Can I figure out the side length measures? No, I have no numbers. I don't have a 5 here. I don't have a 3 here. I don't have anything. So this is automatically out. Now, once again, I don't know anything about my side lengths. So this is also out. And now, it's really just between A and D, because I don't have side length measures. I don't have side length measures, like I said. Now, what is one theorem? What are the theorems that prove similarity? We have the AA similarity theorem, we have the SAS similarity theorem, and we also have the SSS similarity theorem. So it's definitely not anything with the S's, so the only thing that's left is the AA. Do I have 2 congruent corresponding angles? I do. I have this guy and this guy. That's one pair of congruent corresponding angles, and then I have this guy and this guy. That is my second pair of congruent corresponding angles. So I know that this triangle is similar to this one by the AA postulate over here in the corner that I see. So that's why my answer is A. Okay. So now let's go over here. Okay. Determine whether the triangles are congruent. So once again, determine whether the triangles are similar. My bad. So now, once again, look, they give us the order of the triangles right here. They give it to us right here. So let's use that. Let's make, since I have side lengths, let's make an extended proportion. And if the extended proportion are all equal, then I know that my triangles are similar. Okay? So JK to PQ. What is JK? 32. PQ is 40. What is KL and QR? KL is 45. QR is 18. Okay. My LJ is 60. And RP is 30. Okay, right there I already know it's not congruent. It's not similar. They're not equal. LJ is 60. RP. Yeah, because look, 60, because this 60 over 30 is 2 over 1. And I don't know what this is. I'm not even gonna bother, because I know that these are not gonna be 2 over 1. Even furthermore, this is a what? An improper fraction, which means it's greater than 1 because the denominator is bigger, right? And what do I know about 32 over 40? This is just a regular fraction, so this is going to be some small number. This is going to be a fractional number. If I do the math, I don't know, it doesn't really matter, right? Because isn't this going to be smaller than 1? Because it's a 32 over a 40. So this isn't even greater than 1. This is less than 1. Sorry, this is less than 1 anyways, so anything less than 1 obviously is not going to equal to 2. So I already know that this is not right. So my answer should be D. And it is right there. Okay? Because I don't have any angles to go by, so I can automatically cross off this and this. Because I have no angles, guys. There's no angles here. All they give me is side lengths. Okay? So these questions are not hard. You just have to understand what it means by, okay, what does it mean when they tell me what is an AA similarity theorem? What is a SAS similarity theorem, and so on and so forth. Okay? So now let's see this one. Okay? So, explain why the triangles are similar. Okay, well, I already know that they're similar because of this. Look, I have vertical angles. So if I have one pair of congruent corresponding angles and a second pair of congruent corresponding angle, then don't I already know that this triangle is similar to this one? So now I know that they're similar by the AA similarity postulate. So now I want to find X. So now let's find X. So I'm going to set this 80 is to this X, 80 is to the x, as this 90 is to the 135. I'm gonna cross multiply. So let's get my calculator out. I'm gonna cross multiply. What are my extremes again? My extremes are the 80 and the 135, and my means are the x and the 90. So what is 80 times 135? My 90x equals 10800. Divide by 90. Divide by 90. Divide by 90. So my x is equal to 120. So let's see, is that the right answer? Yep. E, which is there is a pair of congruent corresponding vertical angles and a pair of congruent right angles. So the triangles are similar by the AA similarity postulate. And what is my x? 120, which you just found out right there. Now guys, please make sure that you do not pick answer B. Because look, it's going to trick you because it also has AA postulate. And you guys are going to read A, B, C, D, E, and whatever, and you're going to give up and say, oh, well, B's right there because I saw AA. They purposely put this as the first one for students who read A, B, C, D, E, because once they see this and they see that, their light bulb is going to go off their head and going to be like, oh, wait, yeah, I see two congruent corresponding angles. Okay? So let's read this to see why it's not the correct answer. There is a pair of congruent vertical angles, okay, that's true, and the sides that include the two vertical angles are proportional. How can we know that unless we figure it out? How would we know that if this was x? We wouldn't be able to tell that. So that's impossible. So we have to do this one, okay? Okay, so let's look at this. Okay. A hiker wants to determine the height of a tree. So, well, I was gonna draw something that looked like a broccoli. Okay, this is a tree, right? Wow, such an artist. Okay, so a hiker wants to determine the height of a tree. She measures the tree shadow to be 24.7 meters long. So this is the shadow, I guess. So this is 24.7 meters long. Her own shadow at the same time is 2.6 meters. So there's a little person and their shadow is a little bit smaller. It's 2.6 meters long. If the hiker is 1.7 meters tall, so his height is 1.7 meters tall. How tall is the tree? Well, we're gonna set a proportion, right? So what is my proportion gonna be? Well, my height of the height of the man is 1.7 meters to how many meters? X. Let's put X here. To X meters. And my 2.6 meters is to my 24.7 meters. So now let's cross multiply. So 2.6x is equal to, what is 1.7 times 24.7? That is 41.99. Divide by 2.6, divide by 2.6. So my x is equal to, rounded, it's 16.15. So if we were to round it to the nearest tenth, this is gonna round this one to a 2. So that's why my answer is 16.2. Okay? Look at this one, okay? For the pair of similar triangles, okay, so they're already telling me that my triangles are similar. They're already telling me, and we've done questions like this in class already. They're telling me that these pair of triangles are similar. So that means not only are the angles congruent, are the corresponding angles congruent, and look at that. Look, did they need to say to me that these two triangles are similar? Did they even need to tell me this? No, because I have one pair of congruent corresponding angles and a second pair of congruent corresponding angles. So how are these triangles similar? By the AA similarity postulate. So they kind of disrespected us by telling us that, oh yeah, hey, by the way, these are similar triangles. It's like, duh, we knew that, man, right? So let's set proportions. In orange, I'm gonna do one proportion. So let's do from the 90 degree to the no arc is 2x minus 4. What is the 90 degree to the no arc? Here is 24. Now let's do in green the other one. So the no arc to the one arc is 39. And the no arc to the one arc is x plus 6. Okay, cool. So now let's cross multiply. So I'm gonna have 2x minus 4 times x plus 6 is equal to what's 24 plus 24 times 39. 936. This is 2x squared plus 12x minus 4x minus 24, 936. So this is going to be 2x squared plus 8x minus 24 equals 936. Now this looks like a quadratic equation because I have the x2 and the x and a constant. So I'm just going to subtract this guy so I can finish what the actual quadratic equation which is supposed to look like, which is an x squared, an x, a constant, and then equal to 0. So I'm going to subtract 936. Subtract 936. So this is going to be 2x squared plus 8x minus 960 equals 0. I'm going to make my life easier. I'm going to divide everything by 2. I'm going to bring it up here. So now I'm going to have x squared plus 4x minus 480. Now, there's other ways that teachers do this. I like to do, things have changed, I guess, when I went to school, but we would just multiply this by this. And what is this number? This is an invisible 1. So I'd have negative 480. And now I want to find what numbers multiply to give me negative 480 and also add or subtract, or really add to give me plus 4, positive 4. So I'm going to have, okay, does 10 times 48 work? No, because even though these two numbers do multiply, I can do negative 10 and positive 48, or I can do negative 48 and positive 10. They multiply to give me the negative 480, but no way that I can add or subtract this to give me 4. So we gotta keep finding out, and you can just plug in the answer. So let's do 480 divided by 12. Will that work? Yeah. I have 12 times 40, still nothing, so let's keep going. 480 divided by 15. I'm gonna have 15 times 32, still nothing, so let's keep going. 16 times 30, still got nothing. This could take a while. 480 divided by 20 maybe? Yep, right here. I finally got 20 times 24. So now, how can I add these two numbers so that they give me positive 4? I could do negative 20 plus positive 24. And now, this is going to give me, what is negative 20 plus positive 24? That's going to give me positive 4x. So my answer is going to be x minus 20, x plus 24 equals 0. And now, when we set this equal to 0 and this equal to 0, we're going to have x minus 20 equals 0 and x plus 24 equals 0. We're going to add 20, So my x is equal to 20. That's one of my x's. And now minus 24, minus 24. My x is equal to negative 24. Okay, so now my x is 20 or negative 24. Whenever you get a quadratic formula, you have to plug these back in and see if it actually works every time. Sometimes it will not work. So let's do positive 20, okay? So what is 20? What is 20 times 2 minus 4? Well, 2 times 20 is 40, minus 4 is 36 over 39 equals, let's put 20 onto here. So this would be 26 onto 24. Is this true, guys? Instead of dividing, instead of simplifying, all I'm gonna do is just cross multiply, and if I get equal, then I know that that's a true proportion. So 36 times 24 is 864 for these two guys. And now, what is 39 times 26? Wait, I'm doing something wrong. Oh, I'm setting them to the wrong thing. I needed to set this 36 up here to the 24. And then this 39 to the x plus 6, which is 26. Yeah, so now, my bad guys. So now, 36 times 26 is going to equal, let's do it in green and orange to change the color. 36 times 26 is equal to 936. And 24 times 39 is equal to 936. So this proportion is true. So this 20 does work. So 20 is one of my options. Now, what about if we were to try negative 24? Guys, what is negative 24? What is 2 times negative 24? That's negative 48. What is negative 48 minus 4? That minus 4. That's negative, what, 52? Can the length ever be negative? No. So this is automatically impossible because the side length can never be negative. Understand? So the only x that's possible is 20. Okay? So let's keep going. We only got a little bit more. Okay. Are two right isosceles triangles always similar? Yes, because if we have two isosceles triangles, I know that we'll always have, I'm just doing this so it doesn't go away. I know that we'll always have two pairs of congruent corresponding angles. Yes, because the ratios of the sides that form the vertex angles are the same, and the vertex angle is also congruent. Oh, so what I said is not true actually. The reason is because if I have two isosceles triangles, let's say this is 30 degrees. So this is 30 degrees. Oh no, my bad. So now I know if I have two isosceles triangles, don't I know that their opposite sides are always what? They're always congruent, right? Now, what do I know about the vertex angles? They're gonna be the same as well. They're gonna be congruent corresponding as well. So it follows the SAS similarity theorem. Yes, because the ratios of the sides that form the vertex angle are the same, and the vertex angle is also congruent. Okay? Oh, right isosceles triangles. Right isosceles triangles. There you go. So right isosceles, right isosceles. Look, you guys, you gotta read everything. Even I get messed up, okay? So right triangles, so I know that's this is gonna be congruent, and these guys are also gonna be congruent. How do I know that these two side lengths are congruent? Because if I have isosceles triangles, I know that this angle and this angle have to be the same. This angle and this angle has to be the same. And the only possible angles that these two guys can be is what? 45. 45 degrees, 45 degrees, 45 degrees, 45 degrees. And that tells me that this is going to be congruent, and this is going to be congruent, congruent, congruent. So SAS, okay? Now what else? Okay, let's take a look at this one. Is the following solution for the value of x in the figure shown to the right correct or incorrect? Okay, so this is telling me, let's take a look. Okay, this is telling me that they want me to set up a proportion. So I know these triangles are similar because of this, okay? So now, this 4 over 8 should be 4 to the 8, okay? So 4 to the 8, it should then be 10 to the x, if that's the case. If you want to take this route, which is 4, is from, here, actually, it's actually supposed to be 2 arcs. So if you want to take this path and do, okay, from the 2 arc to the no arc is 4. So 2 arc to no arc is 4. And then from the no arc to the 1 arc is 8, okay? So then you're gonna have to set that proportion the exact same way. So what was my proportion from the 2 arc to the no arc? So 2 arc to the no arc is gonna be what? 10. And then from the no arc to the 1 arc is gonna be x. So this is how my proportion should be set up in order to find x, right? Because 4 is to 8, 4 is to 8, as 10 is to x, as 10 is to x, okay? So, or you can think about it, 4 is to 10, 4 is to 10, you see how they're on the same line, as 8 is to x, 8 is to x. I don't care how you guys view it, okay? So what went wrong? Look, this is what went wrong, guys. There was an 8 up here instead of a 10. So the solution for the value of x is incorrect because the proportion does not use the ratios of corresponding sides. That's my answer. We have not learned anything about geometric mean yet, okay? The solution for x, because the triangles are not similar. No, that's not true. They are similar, right? They are similar because of the AA in similarity theorem. The solution for the value of x is correct. No, so this is wrong because it says correct. This is not correct. They are similar, and geometric mean, we haven't even learned that yet. So, and if I were to do this, the value for x is correct because 8 is the geometric mean. No, the geometric mean is something else. That's not true. Okay, so don't worry about that for now. So my answer is B. Last one. How are the SS similarity theorem and the SS congruence theorem alike, and how are they different? Okay. Well, let's take a look at our answer, and we're going to work backwards. So both use 3 pairs of corresponding sides. That's true. But the SSS similarity theorem uses pairs of equal ratios, while the SSS congruency postulate uses pairs of congruent sides. That's exactly what it is. So let's see why the other ones are wrong. So let's look at A. Both use 3 pairs of corresponding sides, but the SSS similarity theorem uses pairs of congruent sides? No, that's not true. So this is wrong. Both use pair of equal ratios? No. Only the SSS inequality, the similarity theorem. The SSS similarity theorem is the one that uses the equal ratios, not the congruency postulate. And both use pairs. No, once again, no, they don't both use pairs. It's only the SSS similarity. Maybe I said inequality by mistake, guys. I'm sorry. If I say that by mistake, my apologies. It's SSS similarity theorem. So that's pretty much it. If you guys have any questions, in class, you can ask me. You can leave a comment too on the video if you want. But